All right, example one. William has some antique bottles. He is going to fill the bottles with soap and give them away as gifts. How many bottles would William need if he has 250 cubic inches of soap? So we know how much soap William has, and we need to figure out how much volume is in one bottle, so we can figure out how many bottles he'll need to fill 250 cubic inches. So I'm gonna start off by just writing down my given information. I know that he has 250 cubic inches of soap. And we know that bottles hold a certain number of cubic inches. We can use what we do know to figure out the answer to this question. So what we do know is that every bottle is 4 inches wide, 3 inches long, and 6 inches tall. So the dimensions are width, length, height, and 4 inches wide, 3 inches long, and 6 inches high. These are the first two things that I've done. And then the other thing that you're gonna do that is encouraged in every single one of these lessons and every single one of your notes is to draw like a quick little sketch. It doesn't have to be perfect. It doesn't even honestly have to be pretty. It just needs to be something that you can use to visualize the real world scenario that you're looking at. You see my bottle looks a little janky. It's supposed to have like a little spout up top, whatever. But it's 4 inches wide, 3 inches long, and 6 inches high. And we want to know how much one bottle holds. So to do that, I'm going to set up my formula first. Remember, write the formula, then plug it in, and then solve. Volume equals length times width times height. Volume equals 4 times 3 times 6. And then you start solving each level one by one. 4 times 3 is 12. 12 times 6 is 72. So volume equals 72 cubic inches. Now we don't stop here. We have to take this answer and put it back into the original question. If one bottle has a volume of 72 cubic inches, we need to figure out how many bottles he's going to need to like have all of these in bottles. So to do that, we're going to take 250 and divide it by 72. And you can do the lone division for this, or you can just be like, hey Siri, what's 250 divided by 72? Siri, hey Siri, what's 250 divided by 72?
250 divided by 72 is about 3.4722.
3.4722. This looks a little weird, so I'm just gonna go back and double check my math for everything. Hey Siri, what's 4 times 3 times 6?
4 times 3 times 6 is 72.
Okay, so what this means is he's gonna need almost like 3.5 bottles. So we could just round this down to 3.5. But since he has a half a bottle that he needs, the answer that we're gonna be is rounded up to the nearest whole number. And we'll say that he needs 4 bottles. Go ahead and take a minute to pause, write this down, get your steps. I'm gonna recap really quickly and just kind of show where we started from. 1, this is what we knew. Here's what we didn't know. And then we did step 1, which is to write our dimensions. Step 2, which was just to draw a sketch of the situation. Step 3 was to use the formula that's gonna help us solve for one bottle. And then step 4, we divided that to figure out how many bottles he would need if he has 250 cubic inches of soap. Which is how we got to our final answer, where we said that he needs 4 bottles to be able to put every one of these cubic inches of soap inside of something. That's the answer for number 1. I'm gonna go ahead, you pause your video. I'm gonna reset so we can do example 2. All right, got my info set up. I am ready to go. I'm gonna zoom in a little bit so you don't have to like squint so much on the screen. All right, so the problem says Damien, that's my brother's name, by the way, is using a package in the shape of a right rectangular prism. So we know that this is a right rectangular prism to ship across the country. The length and the width of the triangular face is, hang on a second. Okay, here we are with example 2. I'm gonna share my screen so we can see that and work on it together. Damien, it's my brother's name, by the way, is using a package in the shape of a right triangular prism to ship across the country. The length and the height of the triangular base are 6 inches and 10 inches respectively. If the capacity of the package is 1,200 cubic inches, will a rolled up poster that is 42 inches long fit in the package? So in order for us to visualize this kind of question, we need to like go in, make our own sketch of what's happening, and then like use that sketch, use that understanding to really like make sense of this real world scenario. So first thing I'm going to do is I'm going to draw a right triangular prism, just like as a sketch, because this is something that I'm going to need to like fully visualize the scenario. This isn't one that comes with an illustration, so we kind of have to make our own illustration. And again, notice that mine isn't going to be perfect. It doesn't need to be. So I draw my bases and then I just connect my bases with like imaginary bases. So what we do know is that this is a right triangle. So my triangle is like a little bogus right now. I'm actually going to draw this as a right triangle just for the sake of understanding. All right, so not a beautiful or by any means perfect right triangle, but it'll do. So think about this as off. Anyway, so here we have, it said that the base of the right triangle is 6 inches and 10 inches. And we don't know how long this is, but we also know that like this is also 10 inches and down here is also 6 inches. So that's 6, that's 10. We don't know how long these are. Okay. The other bit of information that we get here is that the entire prism should be able to hold 1,200 cubic inches. So we do know that the total volume is 1,200 cubic inches. And what we don't have is the length. So we have what we need to find the area of the base, and we need to find the length using what we have. So basically, using what we have, length equals 6, width equals 10, and the height is unknown. We can take what we know and we can use the volume formula to find our missing variable. To do that, I'm going to start by just writing my formula. Volume equals the area of the base times the height. Now I'm going to recognize that I need a more expanded version of this volume formula. So I'm going to start by saying volume equals the area of a triangle, which is 1/2 times base times height, and then multiplying that times the height of my prism. We can even like switch out these base times height and just say length times width so that it still stays consistent with length times width times height. And then I should start plugging in the information that I do have. The volume I already know is 1,200. 0.5 stays the same. I input my value for length, which is 6. Input my value for width, which is 10. And then I still don't know my height, so that's going to stay the same. Now I'm just going to combine like terms. I'm going to make this like one really easy two-step equation. First, by multiplying 6 times 10 for 60. I'm going to bring the rest of my equation down. Every time I do one step, I bring the rest of the equation down so that it continues to make sense for me. 0.5 times 60 is like saying half of 60, which is 30. So now I have 30 times h equals 1,200. And then I divide by 30 because I want to get h by itself. So I'm going to do the opposite. I'm going to do the opposite operation. I'm going to divide by 30 on both sides. 30 divided by 30 is 1, so that cancels out. H is now by itself, and h is going to be equal to 1,200 divided by 30. I'm going to cancel these 0 pairs out. Now it's 120 divided by 3, which is the same as 40. So now we have a height of 40. And we could like throw this back into the original equation to make sure that it works. But if the height is 40, let's go back to what the original question is asking us. This is a height of 40. I'm going to go back to the original question where it says, will a rolled up poster that is 42 inches long fit in the package? Now, that is a question that we can answer because the thing that's trying to go inside of this prism is 42 inches long, which means it's 2 inches longer than what our triangular prism can hold. So the answer to that question would be no, it's not going to fit because the poster is 2 inches longer than the prism itself, it wouldn't be able to fit inside of the box. So this is how you do that. You first draw your sketch of the real world scenario. You organize all of the given information to figure out what you're missing. And then you plug all of that information into your formula. The formula is either going to be length times width times height, or 0.5 times length times width times height when you're dealing with the triangular prism. So pay attention to that. Definitely challenge yourselves, push yourselves to really think through this. I wanted to move as slowly as I could so that this is something that makes sense. If you need to rewatch this video before going to the next page, I strongly suggest it, as well as like taking those notes in your notebook and not rushing. Like, take your time. This is well within your reach, but not if you're rushing, thinking that you can like just go through this. You got this. All right. Looking forward to seeing you guys' responses. Make me proud.